So hello everyone. This is our final project. My name is Ricardo, and my teammate is Shashank. We built a recipe recommendation system, and so our goal is was to build a recipe recommendation system to help on one side to the hospitality industry, and on the other to people with some sort of dietary restrictions or health conditions. To do this, we use the foods.com recipe and interactions dataset that we got from Kaggle. And we think that this exercise adds value to the hospitality and health industry, as it can provide people with allergies or health restrictions with a wider variety of options from which they can pick and choose to cook. In terms of education and awareness, our application, as we will see in a moment, not only provides a recommendation, but also the nutritional values of recipes. So oftentimes we don't know how much sugar or saturated fat is in our food. And finally, it will add value to the hospitality industry, as it will enhance the possibility of restaurants to provide a personalized dining experience to their guests. We used a two-tiered approach for our project. Our first approach was to use a content-based filtering model, which takes a recipe as input and then recommends three other based on ingredients, preparation time, number of ingredients, and number of steps. And while it delivered some promising results, we move forward to a deep learning model, which takes into account ratings and tags associated with recipes. So we can produce not only a recipe-based recommendation, but also now user-based recommendations. And we would like to begin briefly with a demo of our application. So this is our application. As you can see here, the first approach, as I mentioned, you can choose a recipe. You can either choose from the unique recipes that are listed here, or you can directly type in the recipe and you'll get three different recommendations. In this case, the Jiffy roasted corn and jalapeno cornbread, which takes 35 minutes to prepare. It takes 10 steps and 10 ingredients. We have three recommendations, which are the roasted carb muffins, the banana streusel muffins, and the Jennifer S. herb dumplings. As you can see, the three of them take 35 minutes to prepare. Some take 8, some take 10, some take 13 steps, but mostly are constrained in that range. And coincidentally, all of them take 10 ingredients to prepare. So this were the 4 criteria we use for this first approach. And now moving forward to the second approach in our app, I'll let Shashank explain it.
Thanks, Rick. So we also let our users to explore recipes based on ingredients. For example, in this case, let's say I have chosen garlic, salt, and butter as my ingredients, right? I can just keep adding more ingredients to keep filtering the recipes. And in this case, it suggested me these are the recipes which have garlic, salt, and butter. And let's say I go for twisted American chops in this case, which I have selected. It gives me the information about that particular recipe, the preparation time, the description, and also the nutritional information, which would be very valuable for getting to know what you're eating, how much carbs, sugar, and protein does that particular recipe has. And now coming to the part wherein you can use the deep learning model which we train to recommend a particular user certain recipe. So here we can just key in the user ID. In this case, let's say I want to recommend certain recipes for user ID 61250, and I hit recommend. So it should suggest me, recipes specifically tailored for this user based on his interaction with previous recipes, what were the tags associated with those recipes, and what kind of ratings did this user, give to those recipes. So in this case, it has suggested me, 2 different recipes, which have almost similar amount of preparation time and same amount of ingredients. So let's switch back to the deck to understand the motivation behind this project. So we majorly focus on 2 different perspectives here. So first one is from the perspective of person with dietary restrictions, and the other one is from that of hospitality industry. So when we were digging more about those perspectives, we came across few intriguing facts and numbers, which made us think a little deeper about the problem. So here, if you could see, like approximately 10% of the US population has some kind of food allergies, which is associated with more than 170 food types. And 8 major food allergens of those are milk, egg, peanuts, tree nuts, wheat, soy, fish, crustacean, shellfish. And just because of these food allergies, approximately 200,000 people require some kind of medical emergency throughout the year. So that sort of gives you an idea about like the kind of struggle that people with dietary restrictions they have to sort of deal with. And now talking about the perspective of the hospitality industry, so it is evident that like 96% of operators last year reported that they have some kind of delays in supply chain, which makes it hard for them to get hold of certain ingredients in those restaurants. And it is also observed that like personalizing food promotions can also increase ROI. In certain cases it was up to 11x. And it was also observed that consumers would want to have personalized experience, otherwise they'll take their business somewhere else. So now let's talk about the data set that we have leveraged here. So as Rick mentioned, that we have leveraged it from the Kaggle. So it has close to 231,000 recipes, 1.13 million reviews, and we have 4 CSVs that contain all these recipes and the respective user interactions. So the recipe data set has 12 different attributes, and interaction data has like 5 different attributes. Now let's talk more about our approach, and we will walk you through the notebooks in this case.
Thank you. So the notebook for the first approach, the content-based filtering only, after doing some cleaning and pre-processing that we mentioned, we dive into the actual recommendation system, which begins by creating an ingredient matrix, taking each of the unique ingredients, as you can see in the columns, and the recipes in the rows. So for example, Italian soda is used only in 1 recipe, while let's say sugar is used in 1,900 recipes. After that, and normalizing some of the data, we computed the cosine similarity of this ingredient matrix. With it, we calculated distances for the preparation times, the number of steps, the number of ingredients, and then we combined all those 4 measures with different weights. So in the case of ingredients, they were weighted 45%. The distances of minutes were weighted 25. The number of ingredients and number of steps were weighted 15 and 15% each. So this resulted in the scores that we use. So basically, if you see here, emotional balance, spice, mixture, the recipe that it's closest to it is itself, but then we sorted these results in descending order, and we took the first 3 of them to produce the recommendations. So this is the first approach, and now Shashank will also dive into the second approach of our recommendation system.
Thanks, Rick. So I'm going to walk you through the second approach to the recommendation. So here we are trying to come up with a hybrid recommendation system, and that uses both collaborative filtering as well as content-based filtering techniques. So like you start with importing the necessary libraries, you load and pre-process the data, and you pre-process like user IDs and recipe IDs using label encoder to make it ready for the deep learning model. Then you define your test, train test split ratio, which is 80-20 in this case, and then you just like define certain model parameters, which is number of unique users, number of recipes, and then embedding size. And then we go on to define our model. So it's a deep learning model which is going to leverage Keras API from TensorFlow. And it consists of like 2 embedding layers, one for the users, another one for the recipes. And then it just goes on to concatenate those layers. And then it has like 2 dense layers with dropout layers and 1 final output layer. So this model is compiled using the mean squared error loss function, and we use Adam as our optimizer in this case. Then we go on to train our model. In this case, we are training data for 6 epochs, and the batch size is 64 with 10% validation split. And again, like we go on to evaluate our model for loss. And the second part, where we are going for the content-based filtering approach, that's where we sort of pre-process our text features. In this case, that is on the tags column. And then we end up creating a TF-IDF matrix for those recipe tags using the vectorizer. Because we ran into certain computational issues, we had to reduce the dimensionality. So we restricted it to just leverage 100 components in this case. And then we go on to calculate the cosine similarity. So this is like our final recommendation method, wherein like we try to calculate a hybrid score for those recipes by combining first our collaborative filtering prediction, and we give it a weight of 30%. And then 70% weight is given to the content-based filtering, which is on the tags, and it then sorts the recipes by that hybrid scores, and then return the recommendations back to the user. So this was our second approach, which was sort of a hybrid approach. And now switch gears and talk about the key takeaways from this project. So firstly, I mean, like content-based filtering gave us pretty promising results, which are going to be pretty decent enough to be leveraged by person with dietary restrictions, or even in the hospitality industry. And the good thing about current solution is that it gives recommendation not just purely based on recipe, but for a particular user, based on users' prior ratings that he has given to certain recipes and associated tags with those recipes. And no model is good until you put it to use. So we have come up with a pretty easy to use UI for end users to add value to their day-to-day life and business. There were certain challenges that we faced. I mentioned earlier as well that we ran into certain computational constraints. So when we are trying to leverage those individual ingredients to train our model. So in future, what we can do is maybe leverage more features to get finer recommendations with more powerful computational resources. That's about the project. Thank you for joining us today.